Hey everyone, this is just going to be a visual recording of all the solutions for this practice test. The practice test is going to be your best practice for the actual test. That's what it's called that. So I will do my best to make sense. Okay, so for these here, you want to gather your like terms. So the first one here, we can see that x, y, and negative 3x are a like term. So we can add them together. I'm just going to do that straight away. So we've got 8xy plus negative 3xy. And that is just 5xy. And then we can gather the other like terms. We've got a positive 5x and then an x, that's going to be positive 6. Can we simplify that anymore? No, there's no further highest common factors out of those terms. Same here. So how I work out this next one along here is I'm going to multiply all of my numbers. So that's 3 times 4, and that's going to give me 12. And then I'm going to multiply my other like terms. So an a times a, that's going to give me a squared. And then there's a b on the end timesing it all together. And generally, I like to keep things in alphabetical order. That makes it a lot easier to understand. Clear. Okay, so multiplying and dividing. These two have the exact same skill, except for dividing, you need to do keep, change, flip. The first thing it's asking you to do is cancel out common factors first. If you do that, it's so much easier. So with this one here, A, is there a common factor you can see that's going to divide into every term? And the key thing is it's got to go into every single term. 12, 4, and 4. They can all be divided by 4. I could say 2 first, but I know my 4 times tables. Your highest common factor here is 4. So we're going to take out 4 out of each of these things. So 4 out of 12x is going to leave you with 3x inside the brackets. 4 divided by negative 4 is 1, negative 1, I should say. And 4 divided by 4 is also 1. So this is what we want to achieve here. We want to achieve some sort of factor that's the same. And when they're in factor form, that is multiplying by each other, because remember, you've got your sort of invisible multiplication sign in between. When they're in factor form, you can do that lovely slashing, you can cancel out. So that's going to leave you with this 3x minus 1 over 1. We don't need to have the 1, so we will just leave it by itself. Next one here. So with multiplying algebraic fractions, we multiply all the top terms by all the bottom terms. And to do that, it's really important that you put things in brackets. So when I multiply the 3x and the 5x plus 10 on the bottom, it's not just the 3x by the 5x, it's a 3x by the entire right side term. Okay, so I'm going to put everything in brackets, even though they're all sort of singles, just so it's really, really clear. And I'm also going to rewrite this as a single fraction just because it's easy to see. So I'm going to write 5 times 6x on the top. And then on the bottom, I'm going to do 3x, 5x plus 10. And then I'm going to use my arrows. So obviously the 5 and 6x multiplied together, 3x, and then those two multiply as well. So on the top, what have I got? I've got 30x. On the bottom, I have 15x squared, because the 3 and the x multiply, the x and the x multiply, and then the 3x times the 10, that is 30x. And then look what I've got here. That's technically correct. I have expanded out, I've multiplied, but I can make this way simpler, and you always have to give your simplest answer. So I know that there's a number that divides easily into 30, 15, and 30. It's going to be 15. So if I take out 15 out of every single thing, that's going to leave me with 2x here. Oh, actually, there's an even higher common factor. I didn't realize that there's an x term I can take out of everything. So that's nice. I'm going to take out x out of everything as well. And that will be even easier to cancel out. So that's going to leave me with 2 on top. 15x divided by 15x is simply 1. 30x, or 1 squared, I should say. Or x, I should say, because it's an x squared term up here, which I very stupidly ignored. 30x divided by 15x is just 2. So that leaves you with a final answer of, you can cross out those factors because they're the same, 2 over x plus 2. Can you cross out these 2's like so? Absolutely not. You can't do that because you're adding. You can only cross out a like term if it's multiplying or if it applies to every single term. So for, what's it called? Dividing. Don't forget this. Keep the first fraction as it is. change this to a multiplication sign, and then flip this bottom one, this second fraction after the division sign. So 3x minus 3 over 28 multiplied by 7 over x minus 1. Okay, before I multiply the whole top by the whole bottom, I'm actually going to factorize. I'm going to factorize. This makes it so much easier because it means I can do some cancelling out before I multiply everything. So I'm just going to take out the highest common factor from every single set of terms. So that is the numerator on the left, the numerator on the right, etc., and see what I can cancel out. So, and often the clue here is that the diagonal ones go together. So that 3x minus 3, I'm going to take out 3 as a highest common factor, which leaves me with x minus 1 in the middle. On the bottom there, that 28, I'm going to take out 7 as a highest common factor, and that will leave me with it being multiplied by 4. 7, I'm going to take out the common factor of 7. It's a bit weird, but it works. And then on the bottom, I'm just going to leave that as x minus 1. Put that in brackets just for the sake of it. So what we have here is if we look diagonally across, when those things multiply, we can cancel those out. So that 7 and the 7, they are going to cancel each other out. So we can get rid of those. It's like multiplying the thing by 1. The x minus 1, the x minus 1, we can get rid of those because they are also just going to equal to 1. That 1 we'll just get rid of because we don't need to times anything by 1. And this leaves you with a final answer of, what have we got? 3 over 4. And that is your final answer. Take a little screenshot of that and clear everything here. Okay, now we are adding and subtracting. So the key skill here is you have to have everything as the same denominator. And to do that, you need to cross multiply. Actually, rather than finding a lowest common denominator, which is not always the most reliable method, just cross multiply. You get bigger numbers, but it often just works. So your smiley face on the bottom, and then your cross eyes here. So that's your cross multiplication pattern. So let's write it like that. So let's write the denominator first. So 6 times 15, calculate is 90. So the point of cross multiplying is so I can write them all as one fraction with this one denominator. 15 times x plus 4, and then 6 times x plus 3, and it is positive. They're adding in the middle, so I'm going to add that. And then I use my claws, arrows, to multiply everything across. So that leaves you 15x plus 60 plus 6x plus 18 all over 90. Now you're going to add your like terms. So what is like, what can I add? So that 15x and that 6x, they can add. That's nice. That's 21x. That 60 plus the 18, that is 78x. Woohoo. And then on the bottom, you just have your 90. Okay, so we have a suspicion that this can probably simplify down a little bit more. If you don't know your 3 times tables, or the trick for dividing by 3, then you just have to work out a calculator and do some trial and error. But I know that all of these terms are divisible by 3. So I'm going to take it out like this, 7x plus 26. 30. Yeah, that works. So that means that I can cancel out the common factors, which is 3 on the top, 3 on the bottom. So it's only in factor form that I can do cancelling out with this adding and subtracting. And that leaves me with this kind of annoying answer, not very pretty here, but that's fine. You like numbers in all sorts of shapes and sizes. Okay, so same deal with adding and subtracting when you've got a slightly more complicated thing on the bottom. My only advice here is that, put your things in brackets as you normally do. Oops, I should have put them in brackets over here as well. Always do brackets. You can leave your denominator just in that bracketed form, and I'll show you in just a second. So first off, things in brackets. Next off, cross multiplication pattern like this. Next off, rewrite as a singular fraction. So on the bottom, let's write our denominator first. So you only need to do x minus 3, x plus 1, and just leave it like that. No need to multiply that out. It's just going to give you a big long number. Just leave it as it is. Now, then we've got 2x plus 1, and the left to right arrow is 3x minus 3, and then in between it's subtraction, so it's like this. Then I'm going to use my arrows. Okay, and I'm going to be really careful here with my what's it called, negative signs, because negative times negative is a positive. So 2x plus 2 minus 3 times x is minus 3x. Minus 3 times minus 3 is positive 9. Keep your denominator looking like this. All right, and then we add like terms. So we've got a 2x there, and then a negative 3x there. That's going to leave me with negative 1x, or just x. I've got a positive 2 and then a 9 there, so that's 11. And that is all over x minus 3, x plus 1, and just leave it like that. There's no need to go any further than that. Let me just have a little drink break. So those are the basic skills of linear. So factorizing, simplifying, expanding, that sort of thing. Now we actually have to get to the meat of it, which is the solving. So basically figuring out what this stupid x means. My key thing here is, don't forget BidMass. You know, BidMass is actually going to be a very, very handy tool for you. And for solving, we reverse it. So I like to think of an x as, an x is the thing, the mystery that's wrapped up in all these other layers. And the other layers are the plus 3, the divide by 7, etc., etc. And we want to take away those layers by reversing each thing that's happening to it. So the first one here, what can we say about x? You know, x is being multiplied by minus 2. It's also having a 3 added to it. And then on the other side of the equation, that equals 9. So what's the first thing I'm going to do? I'm going to get rid of that 3. How do I do that? I subtract it. If there's just a 3 sitting there, I just subtract it from that side. Remember that we also have that a equation is a seesaw with your equal sign as the little fulcrum in the middle. And with a seesaw, to keep it even, to keep it equal, an equation, what you do to one side, you must do to the other. So that leaves me with negative 2x. I've taken away the 3 there. 9 minus 3 is 6. Wow, great. And then what do we do? Well, at the moment, 2x is being multiplied by minus 2. Let's divide both sides by minus 2. That's going to leave me with negative 2x divided by negative 2 is just going to equal x. When you're not sure if when you're dividing or multiplying your negative signs, just think about it as normal numbers first. So 6 divided by 2 is just 3. There's one negative in there, so there's one negative in the answer. If it was negative divided by negative, then it would be a positive. Okay, so this one, the next one along here, we're going to use our skill of expanding using brackets. So some of you did this pretty well, some of you not so much. This is where BidMass comes into it. So what some of us did was we actually did 7 minus 2, and then we did 5, and then we made that 5 and then multiplied it. That would be very wrong and very naughty, because division, because we do our brackets first when we're solving. So like this, okay? Always that sort of stuff first. Okay, let's work this out. So 6x plus 3, we're gonna leave that there. We've got negative 2x minus 10. Sorry, I just have a visitor. Okay, and now it's just a matter of collecting your like terms. So x is here, negative x there. So that's 6x minus 2x on the left side, keep there. Just a trick, if you're not sure if you should put your x's to the left or the right, just move everything to where x is bigger. So x was bigger on the left, so I'm going to move things there. So now I'm going to gather up my other terms. So I'm going to get rid of this 3 by minusing it from both sides, minusing it from that side here. Okay, so on the left-hand side, I have 4x. Then I've got 7 minus 10 minus 3. 7 minus 10 is minus 3, minus another 3 is minus 6. All right, so 4x, how do I get rid of that 4? Divide by 4 on both sides. That leaves you with x equals negative 3 on 2. Just made a big mistake, I realize actually. Sorry, let me just get rid of this. This is what happens when you don't do everything properly. Okay, so to get rid of that 2 on this side, I'm adding 2x to both sides. So I've got 8x on the left-hand side, minusing 3 from the L left-hand side, adding it all to the other side, leaves you with minus 6. Divide both sides by 8, x equals negative 3 on 4. Sorry about that. Okay, so with inequalities here, don't be too worried about the funny signs. My advice is to solve them exactly like you would a normal equation. And then if you're dividing or multiplying by negative, then you switch it around. This first skill here is just looking at the number line and figuring out what have we got, where are the numbers. So that first one is basically saying x is to the left, so smaller than 1. So I'm going to write x here is smaller than 1. That's where it is. Could x be 1? No, it's not. It's not checked off. If you wrote 1 is smaller than x, that would also be correct. So over here, x is bigger than minus 4. So I'm going to do x is bigger than minus 4. Could it be minus 4? Yes, because it's checked in like that. Over here, we have a limit. So x, I'm going to write x in the middle because x is smaller than something and bigger than something. What is smaller? What is x bigger than? X is bigger than minus 1 on the left, and it is smaller than 3. Could it equal either ones? Yes, it could equal 3 because it's checked in like that. So I'm going to solve these inequalities like I would an equation. So on the 6a here, I'm going to add 3 to both sides. So that leaves me with 4x is bigger than 20. Divide both sides by 4. X is simply bigger than 5. That's all that is. And the next thing there, this might ask you to draw that on a number line. So if I were to draw that on a number line, I'd have 1, 2, 3, 4, 5, 6, 7. You just write your little arrow there for x. That arrow means like goes off into infinity, and no, you don't draw it in. Okay, so this next side here, I want to get rid of my brackets first. So over on the right hand side, I've got 4x minus 8. I'll just rewrite this part here. Let's get all the, now which side should I have my x's on? I'm going to move all my x's to the right hand side of the equation just because that is easier. It means that you don't have to fiddle around with the negative signs. So I'm going to get rid of my x's on the left, get rid of my numbers on the right by doing the reverse operation. So on the left hand side, I have 10. On the right hand side, I have x. If you had done it the other way, moving your x's to the left, you would have gotten x is greater than or bigger than 10 because you would have switched the signs around. This. Okay, so this is where things may start to get a little bit trickier. We're doing simultaneous equations. So simultaneous meaning at the same time, substitution meaning placing one into the other. So basically the point is here that you are trying to find, these are 2 lines, they're crossing over at some point. What is the point in space where they're crossing over? So we're looking for, our final value should be an x value and then a y value. So x equals something, y equals something. And if it's a worded question, it might be like dogs equals 2, cats equals whatever. So the very meaning of an equation is that equals, you know, we've got our seesaw sort of symbol here. Whatever's on this side is the same as on that side. So that equals this, equals that, equals that. I could do equal signs between all these things, so they'd all equal each other. So that means whenever I see this y here, I can replace it with any one of these other phrases, the 5x phrase, the other y phrase, or the 2x phrase. Just so I've got actually something to work with, I'm going to replace it with the 2x phrase. So 2x plus 5 equals 5x plus 14. And now you've got it like this. You can just solve it like a regular equation. So what am I going to do? I'm going to move my x's to the side where they're bigger. So I'm going to subtract 2x from both sides, meaning that I'm going to subtract my numbers from the other side. So subtract that 14 there. Just do some quick mental maths. So I've got 3x being equivalent to -9, meaning that x is equivalent to -3. Okay, I like to put that in a little square just so I can keep that there. At least I've got one part of the equation. So in my final answer, I know that -3 is the x part of the coordinates. Then what I do is I sub that value into one of the equations. That's equation 1. There's equation 2 up there. 2 looks simpler to me, so I'm going to use 2. So that means that now I've got what x equals, this number here. I can substitute it into that x spot. So y now equals, let me do the right color. Y equals 2, let's drag this, and then -3 instead of writing an x now, plus 5. And then we simply solve. So 2 times -3, -6, plus 5, y equals -1. That's your final answer. That's that, like that. Cool. So same substitution method for the next one along. You just have ever so slightly bigger numbers here. So again, like we have before, when you're not sure whether you choose substitution or elimination, I like to use substitution when I have an x or a y without a coefficient, so with only one, because that means I can easily substitute that, which is that, into that little bit there. So be careful here. I'm not substituting this with 2y. I'm substituting with just the y part. Okay, so just that y part. So what I've highlighted there, that's what I'm substituting. So let me rewrite that there. So 3x, I'm going to call this equation 1, equation 2. So 3x minus 2, and instead of writing y, I'm going to write 2x minus 5 equals 18. Okay, so then you just expand like normal, always expand your brackets out first. That's pretty much the first thing you ever do. So 3x minus 4x, and then -2 multiplied by -5 is 10. Be careful if your negative signs there. A lot of us got mistakes. And then that equals 18. So again, what you're going to do is going to gather your like terms. So these two gather. So 3x minus 4x is -x. Plus 10 equals 18. What am I going to do next? -10 from both sides to get rid of it here. Now, -x equals 8. That's great, but we don't like negative x's. They actually kind of don't really mean, they kind of don't make sense. So how do we get rid of a negative sign? Well, x is 1x, so x is -1x. So we do the opposite. We divide it by -1. Meaning that x is -8. Okay, great. There is my first solution there. That is negative. And then simply sub that into, I'm going to sub it into equation 2 because it looks way simpler. Just, it doesn't matter. Remember, it doesn't matter which one you sub it into. I am just feeling a bit lazy, so I'm going to sub it into the simple one. Okay, so that means I write equation 2. So y equals 2. And there's the -8 there from the 4, -5. So there's that -8, -8. Expand like normal. Y equals -16 minus 5. Y equals -21. So that is your answer. Kind of long, kind of cool. Yeah, it works. Let me just pause for a second to have some. Okay, so elimination here basically means you want to slice out one of those pesky little variables. Okay, so the first one on the left here, sorry, I didn't go straight to an easy one. We have to do a little finagling. We have to multiply something around. So the first thing I'm going to do is I'm actually going to name my equations. I'm just going to give them number 1 and number 2, just so I know which is which. The next thing I'm going to do is decide which variable I'm going to get rid of, the x's, 3x and 2x, or the 2y and the y. Now, 2y and y, they're going to be simpler to multiply. However, they're not the same size yet. One's a 2y, one's a y, meaning that I can multiply the entire second equation by 2. And that will mean that they're in the same size now. So I'm going to multiply that entire second equation by 2. So I've got now 4x minus 2y minus 10. And that will give me a new equation, number 3. So the reason why I can do that is because if I multiply both sides of the equation by the same number, it equals the same thing. Yeah. So basically, once I've done that, I'm just going to sort of leave 2 in the dust. I'm ignoring it for now because I've got its better version 3. So name the equations, decide which thing to subtract or minus from, maybe do some multiplication if you need to. Now, the fourth step is here. Are you adding or subtracting here? So here's a good little tip. If the one's a positive and one's a negative, then you add them. However, if they're both positive, then obviously you need to subtract because you need to take one from another. But also, if they're both negative, you also need to subtract. Shout out to LM, you know who you are, for giving us that tip. So there is something maybe you want to write down. So if they're the same sign, subtract. If they're different signs, add. Okay, so clearly the 2y and the negative 2y are different signs. So what do? We add them. Okay, so I'm just going to add top to bottom. So 3x plus 4x is 7x. 2y plus negative 2y is nothing. So you just get rid of that actually. And then negative 11 plus negative 10 is negative 21. Okay, if you can't do it in your head, that's okay. Just use your calculator. So negative 11 plus negative 10 is 21. So nice, that worked out pretty well for us. So we've got 7x equals negative 21, divide both sides by 7. So x, nice and simple, equals negative 3, easy. So we've got that symbol there. And now once we've got one of the variables, we can easily sub that into any of the equations. Remember, it doesn't matter which equation you are going to use. I am going to bring out equation number 2 from retirement, just because it's been like not doing much for us lately. So I'm going to use equation number 2 and so put in my solution for x. So this is great because now I only have y. Y is the only thing that I need to solve for now. So I'm going to expand those brackets out. So 2 times minus 3 is negative 6, minus y equals minus 5. I'm going to get rid of that plus 6 and that's negative 6 on this side. So I'm going to add 6 to both sides. Minus y equals 1. We don't ever want to have a negative x or equaling or negative y. So what do? We divide both sides by negative 1. And that will give you your final answer of y equals minus 1. So your final answer here is minus 1, minus 3, minus 1. Okay. Yeah, that's all well and good. We're actually going to leave the second equation here just because it's a bit complicated. We're not going to do that on the test, so all good. Let me clear and let's move on. Let's move on to the next thing. Okay, lucky last one here. So this is a word problem and you have to basically decide if you're going to use elimination or substitution to find it out. I think the hardest part with this sort of stuff is writing your variables. So this question doesn't say write variables, but this is what you should do. So read the question and get a sense of it first. So Jody, she buys 3 popcorns and 5 small drinks. Pretty nice. So she got 3 popcorns and she's got 5 drinks. And it costs this amount of money. Renee also gets 4 popcorns and 3 drinks for her friends at a cost of $23.50. So to me, this is reading like x plus y equals something, x plus y equals something. So it's clearly simultaneous equations here. I'm going to write what the variables are. So P is popcorn, just so you're really clear on what's what, and D is drinks. 2 equations. So the first one here, Jody. J is not part of the equation. It's just what we're calling that equation. So we can call that J. She got 3P plus 5D equals 24.50. And what's her name? Renee is gotten 4P plus 3D equals 23.50. Okay. Now, what do? So are we going to use substitution or elimination? So remember that substitution is best when we have our equation being just a y equals 2x plus 21, or just an x. So substitution is not our friend today, because we can't just get just p equals something. We don't have p by itself. So we're going to have to use elimination. So with elimination, we've got two equations. We've got j and we've got r. And we want to cut out one of the variables. So have a look and see which is preferable to cut out. Doesn't matter which you start with, but I always just go the simplest one. Why not make it easy? So I'm going to cut out the 3p and the 4p just because they're smaller numbers. That's it. So what I need to do is actually make them the same number. I need to make 3 and 4 the same number using multiplication. Their lowest common factor, the number that they're both going to divide into, it's, let me just count, it's 12. So 12. If you're not sure, you can just cross multiply, times it by the other. So that means I need to multiply this whole equation by 4 from here, from Renee. And that means I need to multiply Renee's equation by 3. Okay, so let me just do that. Let me just color code that, so that's a bit easy to see. I need to multiply Renee's equation by 3, just so, because we're eliminating the popcorn, and that's the thing that we want to have in the same value. So let's make that new equation. So I'm multiplying the top row now, so I'm going to be writing in red. So we've got 12p plus 20d equals 2450 times 4, calculate, is 98. Okay, and I'm going to call that equation A, just so I've got something to call it. Doesn't really matter what it is. Now, second row. Now we need to multiply this entire second equation, so Renee's stuff, by 3. So to get that 4p equaling 12. So 4p times 3, 12p as well. 3d times 3, 9d. 2350 times 3, calculate, $70.50. Okay, so I'm going to call that equation number B. And using our method from before, do you add, do you subtract? If they are the same sign, so both positive or both negative, then you subtract. So this way I'm going to subtract one from the other. So 12p minus 12p, 0. Great, that's exactly what we want to do. That was the whole point of messing around with that times 3 times 4. 20 minus 9 is 11. 98 minus $70.50 is $27.50. Okay, that was not too painful, I guess. And now you need to multiply both sides by the 11 to just get the d by itself. So calculate, that equals $2.50. A bargain. Excellent. So now you've got $2.50. Strings equals $2.50. Put a little dollar sign there, just shows you know what you're doing. And now you sub d equals 2.5 into any one of your equations. I'm going to sub it into there, just because that looks nice and easy to me. So I've got 3p plus 5, 2.5 from the actual thing equals $24.50. Okay. So what is 5 times $2.50? Calculate it. It's $12.50. And just bring the rest of the equation down to the next level. Now you want to find out what p is. So you're going to get p by itself. Let's get that $12.50 out of there. So let's subtract it from both sides. And that will leave me with 3p on the left equaling 12. Nice. That was not too bad either. Now let's divide both sides by 3. So you have popcorn being equivalent to $4. Woohoo, nice. That is how much everything costs. And then if I had the energy, I would place those back into the equation and check that I was right, but I know I am, so I'm not going to. And good luck and bye.